2, how can I predict the area? So we're going to move into perimeter and area of enlarging patterns. In this lesson, you will build your understanding of geometric relationships and reinforce your algebraic skills of representing relationships in multiple ways. You will create tables, graphs, and equations as you explore how the perimeters and areas of patterns change as the patterns are enlarged. So, Carpet Mart. Your friend Alonzo has come to your team for help. His family owns a rug manufacturing company which is famous for its creative and versatile designs. One of the most popular designs is shown at the right. Each rug has its own original size as well as enlargements that are exactly the same shape. So figure 1's the original, and then it's getting larger. Alonzo is excited because his family has heard that the king of a faraway land is going to order an extremely large rug design for one of his immense banquet halls. Unfortunately, the king is fickle and will not decide which rug he will order until the very last minute. The day before the banquet, the king will tell Alonzo which rug he wants and how big it will need to be. The king's palace is huge, so the rug will be very big. Since the rugs are different sizes, and since each rug requires wool for the interior and fringe to wrap around the outside, Alonzo needs to quickly calculate the area and perimeter of each rug in order to obtain the correct quantities of wool and fringe. So obviously, again, area is like how much is in the middle. So area would be how many of these squares there are. Perimeter is the distance around the outside. So your task, investigate one of the rug designs. The original rug is shown in figure 1, while figures 2 and 3 are the next enlarged rugs of the series. With your team, create a table and a graph, and then write equations for both the area and the perimeter of your enlarging rug design. Then decide which representation will best help Alonzo calculate the area and perimeter for any figure number. Be ready to share your analysis with the rest of the class. Your work must include the following: diagrams for the rugs of the next two sizes, figures 4 and 5, following the pattern shown in figures 1, 2, and 3. So we have to draw figures 4 and 5. We need a description of what the 20th figure would look like, what the area and the perimeter are, a table, graph, and equation representing the perimeter of the enlarging rug design, and a table, graph, and equation representing the area. So, I don't know what just happened right there. I somehow managed to close the program, I guess, so I apologize for that. That was unexpected to say the least. All right, so as we move down, I'm going to go ahead and I'm going to pick figure B, just because that was the one that they used up here. And again, we want diagrams of the rugs for 4 and 5, so I'll make 4 and 5, and then I kind of go from there. I will say also that the book shows some further guidance if you look in the textbook. So the further guidance, just if you struggle to do these tasks right here, if you're struggling to do these tasks, the further guidance section essentially just tells you some hints to make those things happen. And then at the end, we'll answer question 135. So to go back here, what would figures 4 and 5 look like? Well, let me set this up real quickly. I mean, obviously we get this shape here. So let me go ahead and go to the straight line tool. So we get the shape where it kind of gives the same basic shape for each of them. So I'll just go ahead and draw that same basic shape, and then what we'll do is just sort of look and see. It's not going terribly well. There we go. You can see like it has these original sort of sections here. So I have these 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. But what you'll notice is in each of these, like this particular block right here is a 1 by 1, and then it's a 2 by 2, and then it's a 3 by 3. So it seems pretty likely that it would be a 4 by 4, right? That all of these would be 4 by 4s. And this is going to take a little while and not look the greatest. But you can see that that's what we're coming up with. I might have put an extra line there on that. But again, 4 by 4. So if I want to, I can have my perimeter and stuff going, but I guess I'll save that for a second. So if I want to do the figure 5, again, it's going to be the same thing. It's just obviously that I'm going to have a 5 by 5 instead of a 4 by 4, which again, kind of a pain to do, but I think I'm going to start again with that the initial squares seem to kind of make this easier to do. And then from there, I know I'm going to have 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5, and then same thing, 2, 3, 4, looks like maybe I'll have to go back up here, 5, 2, 3, 4, 5, and then 2, 3, 4, 5. So again, in each of those, we get that little shading if you want, but that's essentially what it's going to look like. As a matter of fact, let me see if I can shade. I'm not sure if I can anything better, but at least you can see what I was trying to do here, where these gray boxes are 4 by 4 and then 5 by 5, and the white boxes again 4 by 4 and then 5 by 5. All right, so what would figure 20 look like? Well, figure 20, we don't actually need to do this again, thank goodness, but I think just a quick description of figure 20 would, we'd have the same original 6 boxes, and each box would be 20 by 20. And I think that's a pretty decent description, right? We have these original 6 boxes, but in each original box would be a 20 by 20 inside instead of what it is already. All right, what are the area and the perimeter? So the area, well, that's an interesting question. We haven't really actually even gone into the area and the perimeter of these yet, right? So I think what makes more sense is let's go ahead and figure out what the area and the perimeter are. Let's go ahead and make tables and see if we can make equations that sort of go with these. So if I were to go with my area and my perimeter, the original one, all right, so my input is essentially going to be figure 1, figure 2, figure 3, figure 4, figure 5, and again I'm going to go down to figure 20, all right? I'm going to have a jump in there. My perimeter, again, my input is just going to be which figure I'm looking at, whereas my output will be what it actually is. So my area, the first one is 1, 2, 3, 4, 5, 6. Pretty simple. Here it's 4, 8, 12, 16, 20, 24. So you can see I'm just counting by 4s here. Here I need to count by 9s, right? Each box is 9. And there's 6 boxes, so 9 times 6 is 54. It'll probably be a little bit faster to do it that way. Here I have 16 times 6, so I'm going to get 96. And here I have 25 by 6, which is going to equal 150. So the question is, what's my equation here? And you'll notice it is not linear, because if it was linear, I would just keep adding 18 each time, and that's not what's happening. So one of my favorite things in math to do is to kind of look at these patterns, because I think they're so cool. What happens is you'll notice that on the first level, there is no sort of common difference, but on the second level, there is. So what that means is that my equation to this, for this area, is y equals something x squared, right? So we know that something is going to be squared, and hopefully it's obvious that when I plug 1 in here, 1 times 1 is 1 times 6. When I plug 2 in here, 2 times 2 is 4 times 6, get 24. 3 squared is 9 times 6 is 54, 4 squared, and that's literally what's squaring, right? This box is squaring, and I have 6 of those boxes. So it makes a lot of sense what this equation ends up looking like visually. So what would it look like if I plug 20 in? Well, 20 times 20 is 400, and 400 times 6 would be 2400. So the area of this would be 2400. But what would the perimeter be at figure 20? Well, if I go with the perimeter again, and again, it's kind of a pain to count here. So I'm going to mark where I start. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's just the distance around the outside. So I'll do the same thing. I'll mark. That way I do this mark just so I don't keep going past it. So here's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. All right. So let's count here. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42. It looks like I am beginning to have a common difference of 14. So this one looks like it might be linear. So it'll be interesting to see if this one ends up being 56, right? So let's try that. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56. So there we go. It was 56. I can feel pretty confident that this one is going to be 70, and you can verify that for yourself if you want, but essentially it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 runs of 5, and 14 times 5 is 70, so that looks pretty good. So my equation here, my y-intercept is obviously 0, but my slope is 14, so it looks like y equals 14x is my equation. And again, if I plug 1 in, I get 14. If I plug in 2, I get 28. If I plug in 3, I get 42. 4, I get 56. So what happens if I plug in 20? Well, it looks like 14 times 2 is 28 with the 0 at the end. 280 would be my perimeter of that one. All right, so it says a graph. So I'm sorry, I'm sort of jumping around here. So here's where we're at. Diagrams of the rugs, the next two figures, 4 and 5. We have figures 4 and 5 drawn here, here and here. Description of figure 20, we have figure 20 described, what it would look like. We also have the area and the perimeter of figure 20. We have a table. We do not have a graph, but we do have an equation representing the perimeter of this rug and the area of this rug. So what I guess we're looking at is just real quick, nothing too crazy, right? Let's just make a graph here. So 0, 1, 2, 3, 4, 5. You can see my scale gets rather large rather quickly, so we'll go up to 150, which means we'll make this 125. We'll make this 100, 75, 50, and 25. So we'll graph that. 1 and 6 goes here. 2 and 24 goes here. 3 and 54. So it's beginning to rise. 4 and 96. Actually, that one would be better down. It was down a little bit there. I think I went a little too high. 354 should have been more like right there. 4 and then 5, 150. So you can see we're getting a curve. Definitely getting a curved shape there. If we go here, you can see it just goes to 70, so nothing too exciting. So we'll make our scale here. Again, we have 0, 1, 2, 3, 4, 5. And we can make our scale go 75, 50, 25. So nothing too exciting. So 1 is 14, 2 is 28, 3 is 42, 4 is 56, and 5 is 70. And you can see we definitely have like a linear graph here. So here is linear, which makes sense. Linear equation. Here is, it's what's known as parabolic. It's a quadratic. We're making a parabola. Actually, it looks something like that. We'll learn that later in the year, but for now, we do not know that. All right, so now it says where we're at. Kind of jump over to the last question here because we did all this stuff. It says the king has arrived. He demands a rug number 100, which is figure 100 in your design. So how much fringe does he need and how much wool does he need? All right, so we'll go back over here. If I plug 100 to this equation, a calculator is going to be pretty helpful, right? I think. Uh-oh, that didn't go the way I wanted to. So again, we're going to go with figure 100 on both of these. Probably could have left more room for myself than I did, but I hope you see what we're doing. We plug 100 in, so we're just going to say it's 100 squared, and then we'll multiply that by 6. So he needs 60,000 for the area. Fairly large number. And then here, obviously, it's just going to be 1400, right? If you plug 100 in, you just put 2 extra zeros. So a lot going on. Again, there were several shapes. I'm just doing one of the shapes. In class, group by group, each group would have got a different shape and had to have done essentially the same thing. So that is lesson 122.